This is Luke Robbins. I just wanted to do a quick update video because I realized when I originally uploaded my YouTube viewer, it was kind of before I just implemented a couple last things. So after putting that off, here's just a quick demo kind of going over some of that stuff. So for the converter, nothing too surprising. Essentially just going to take those vertices that were grabbed from the FBX file, package them up into individual little chunks, include the textures, and export that to a type that can be easily read into the engine, and then from there rating them in. So I'm just going to get going with a quick demo of the kind of command line option and then what it looks like in the actual converter itself. So here we go. I'm just using the executable in the debug folder, but if you could just include this in a standalone folder so that you could just run it, executable with .. slash resources slash warbear. But anyway, here's an example of one just converting the warbear. So it'll run, and we can see here. So I generated blow files for texture. I'm sorry. Before I get to texture, there's the vertices, the norms, the UV, and the trilist, which is the indices. And so the main components of the vertices plus texture. You can see here that there's two textures because it found both the it found the one that was the polar and the one that was the grizzly. So both textures are included in a single SPU file. And so if we look at the actual converter and just hit play here, we can see kind of what that execution looks like. So here we go. The first thing that we kind of go past the individual stuff, which was done to compile the vertices, and then we look at how we get these into a package that we can work with. So pretty simple stuff here, just using the number of vertices and the size of, either XYZ data or UV data or norm data, and just getting 3 individual buffers for that information of the relevant sizes times the number of elements. So we get those buffers and then just use some kind of pointer offset to chunk those into their components. I know you could probably just write the vertices as is, but while this is slow and kind of clunky, what it does do is put the data in nice individual components so that you don't have to rely on a specific format. So once we do that, we get down to trilist data, which we can just do in a single kind of mem copy. But even though I guess I did it here the long way, but you could just get the data and then write that as a single buffer. So once we do that, we move on to just writing some of this information to file. So all we do is just use our file facilities to write a bunch of bin files. So you can see they're named kind of programmatically here. So it's like name underscore verts type, and then this will be name underscore UV type, trilist type, and then eventually we'll get over here. So now we're loading the textures. I just had this sort of like regex, whatever, regex, or whatever you want to say, expression. So we use the root word of the file with an asterisk. So now this is going to look for all files that begin with this and end with a TGA. So this is going to get the verts type, the norms type, and so this way we can kind of package them all in a single go. And what we'll do is we'll find all the names in the directory for that, and what we'll do is then read in the sorry. So all the textures would have followed this format. Sorry, not the others. We'll get back to the vertices, but this is finding all files that are textures for this that begin with a certain name, so they have to follow that protocol. And so if there are any of these, so there could be no textures, and we just would skip over that. But if not, we get the name of the texture file. For this one, there's just one, and it's falconheavy.tga. We open that file, read that data. Read that data into a buffer after getting its size, and if the size is greater than 0, we'll use that buffer, close the TGA, and we'll write that information into kind of our file with our header appended on it. So we take the TGA, and all we do is just put a nice header on it so that we know what to read later. And we can see current texture is Falcon Heavy 0, because if there were multiple, you would see Falcon Heavy 1, Falcon Heavy 2, and the engine could read those individually. And we'll call vodka on that. And so now the other ones we'll free all that memory that we used, and we'll call vodka on the rest of them. And then at the very end, we'll call a single LIU call to wrap all of that up in a single SPU package. And you can see there in SPU, it'll print out what it's including. So it's including all of those. And this was just the old implementation, so I'll continue. We're not actually going to use Falcon Heavy, but so we can see here, yeah, we can see we just converted that. But more importantly, from the command line, we converted warbear.spu at whatever 436. So we've got, so I already did that for multiple of these. So I've got all the ones from all these groups. I've got Astro Boy, the Buggy, the Warbear, and Falcon Heavy I used as my model. And so we have all those ready to read up into the engine. And there's texture, and it will read that custom data type. So let's go. So let's load up the engine here, and we'll we'll play this and kind of look at some of the more interesting features of this. So in loaded model, this is a special class designed for loading these types that are created by our converter. So we'll use the name. So for instance, here we're looking at spacefrigate.spu. So we'll load this up using eat. Okay, eat found it and loaded up a buffer with the data from the Space Frigate SPU, which will contain its vertices, indices, and stuff like that. So the first thing we did is look for the verts type. Okay, we'll get the vertices, the XYZ, then we'll load up the chunk of UV, etc., etc. So here we got the vertices and the number of vertices based on just some math. And so let me show you what happens inside of eat to get that chunk of data. So we find the file name, and what we do is we iterate through the SPU file, and if a chunk has a header that is the same type, so if the chunk header.type is UV type, because that's what we want, and if the name is Space Frigate, then we will return that information. So didn't find it, didn't find it, didn't find it. Oh, here we go, we have a match. And so now we'll get that information, which is UV type for Space Frigate, and we'll return that. So now we have all these buffers, and we have the sizes of these buffers. And so now for texture, it's a little different because we could have multiple textures. And so you can load in a variable number of textures. So we'll get a texture name. So this will probably be Space Frigate 0. Yep, that's what we start with. And we will look for that texture name within that same SPU. We're looking for texture type and name text name. So Space Frigate 0, and we're going to find it because we have 1. And since we found it, we now add that texture into our engine since we found it. And so now what we'll do is, we'll load texture from buffer because we got that data from eat. All we did was package it into the header. And this is just going to be TGA data. And so now we're going to process it as TGA data. And we're going to give that to kind of a new node here that's going to hold it. And so the way the textures are organized is actually using a PCS tree so that I can flip certain textures a certain way. So for instance, Warbear will have 2 textures, but Space Frigate will have 1. So when I hit texture flip, Warbear will switch from Grizzlies to Polar Bear or vice versa, but Space Frigate will not because it has no other textures. If we had multiple Space Frigate textures, it would loop between those, but it wouldn't just give it a random texture. And so here we go. We've got this. And when we add it here, what happens is each one of those, like Warbear, Space Frigate, they'll have a root underneath the main texture root. And if one doesn't exist already, when we first load it up, what it'll do is it'll actually create, a parent root node for this. So no, can't find it. Okay, and since we can't find a parent root node, we create a root, which is just going to be like a null holder. And then once we have that holder, we'll actually add the root itself, the node itself to the root. And so we'll do that. We'll keep and add, insert using that new root node, and then we'll continue. So we've loaded up the texture, we loaded up the UV, the norms, the vertex data, and once we're done with that, we've got this entire kind of thing ready to go here. And here we can see we're just creating new vertices from all that raw data. So we'll loop through all of the, the XYZ, we'll loop through all the UV, we'll loop through all the norm, and we'll pack all of that into a single vertex. And then we'll add those vertices to the model. And we can see here we're allocating a try list and allocating a vert list and using that data that we just read in. And so now we've done all of that, and we can kind of continue. So there's the frigate, and then that will continue for the next one. So let me get rid of these breakpoints so that we can actually start to see this running a bit. And you can see kind of what the models look like. And here I'm just showing you that I instanced the Warbear, so I'm looking for one that was Warbear 0. And then continue. And we can see displaying here. So if I hit C, I'll change cameras. So we have A, which is, well, I guess I swapped out Astro Boy, but that was in my previous iteration. But I've got the frigate, and I've got D, which is Falcon Heavy. I've got the buggy. I've got the Warbears. I wish I had left Astro Boy in here, but I was playing with Texture Root. If I hit B, I can make those bounding boxes appear. In the bounding box, you can see it changing as it goes in and makes contact with the edge of the frame there. Bounding boxes, what I did was I have a separate root on the Game Object Manager root. And so it's essentially just a different type of game object, and I can toggle those types of game objects on and off. And the other thing I can show you is texture. So if I hit, oh god, I think it's T. Yeah, the textures are swapping. But for all these other models, they only have one texture, and they're not just going to swap to a random one. But the bear has two, so it's going down, hits the end, goes back up. And then I have a model for kind of the camera frustum from camera 0. And so that's kind of showing how the converter works and how I loaded up all this data, so hopefully that looks good.